And I hope you also love it. Very good. So we are still getting through the course trigonometry. And now we are at sum and difference identity. Sum and difference identity. That is having cos into bracket a plus or minus b, or sine into bracket a plus or minus b. In fact, I'm going to introduce this to you and you will love it. We will go through how to prove for cosine, and we can link that to get sine. Very good. Now, before everything, you have to know that several examples presented earlier should have convinced you by now of something. And what is that? And that is cos A minus B. By now, you should be able to know that cos A minus B does not equal to cos A minus cos B. It doesn't mean that we are distributing or we are expanding to break the brackets. It's not like that. The whole of A minus B is an argument. So this is not the same as this. Okay, let's prove. Alright, let's prove. So let's assume that let's put A to be equal to, let's say, pi on 2, then B to be equal to 0, and see what you're going to get. So let's look at for the left hand side. For the left hand side, you're going to get cos pi over 2 minus 0. Is that also very good? So what will you get for? So now here you're going to do it in this way. Pi over 2 minus 0 will give you pi over 2. So this is the same as cos pi over 2. And that is going to give you 0. Thank you. What about the right hand side? What about the right hand side? That is cos A minus cos B. So cos A is pi over 2 minus cos B, which is which is 0. Alright, so here cos pi over 2 is going to give you 0. And cos 0 will give you 1. So with this, we get negative 1. Oh, I hope you can see that. The result here is 0. The result here is negative 1. So that is telling you that cos A minus B is never the same as cos A minus cos B. Hey, no. So as a mathematician, when you express something to be cos, no, child, never like that. So that is why we are in this video. Okay, that is why we are in this video. So we can now derive a formula. For cos A minus B. For cos A minus B. So we are going to start by locating the angles A and B in standard position. On the unit circle. And I have taught you what a unit circle means already. Alright, so we are going to do that on a unit circle, whereby and assume that the B is going to be greater than A. Right, we are going to take the B, but we are going to take the B to be first less than A. That is why it is A minus B. Alright? Because if is greater than the B, there is no way when you subtract this from this, you are going to get a negative argument. No. So we are going to take B to be less than the A. Alright. And also, I'm coming. Let me give you the diagram of the unit circle and explain it to you further. Nice. Nice. So we can now derive a formula for cos A minus B, where B is greater than A. That means that there is no way when you subtract this from this, it's going to give you a negative argument. No. So now we are going to let S, that's the point here. Now from the unit circle, you know that from a unit circle, the radius is 1. Very good. The argument from here to here is A, and the argument from here to here is A minus B. That's going to be A minus the B. Alright. And it's going to be the point Q. The point Q is what we have here. That is that. So that's the point Q, that's the point P, and the point S, the point R, and that. Very good. Very good. So we are going to let S and Q be the points where the terminal side of the angles A and B. So the point S and Q here is representing the terminal side of angle A and angle B. Very good. Alright. Now, you have to also see that this intersects the circle. This is intersecting the circle. And that's why we have located, so that's why we have located point R on the unit circle. And that point is what we have there. And that point is what we have there. So that angle POR, the angle POR, that is POR. This bigger angle is what we are referencing here. The angle POR is going to be equal the difference of A minus the B. And that is what you can see here. Very good. Let me give you some important notes for us to continue with the proof. Alright, so now the point Q is on the unit circle. The point Q is also on the unit circle. So by the work with circular functions, that is what we have previously done. We have done circular functions already. The S coordinate of Q, is the cosine of the angle, and the B is the cosine of the angle B, while the Y coordinate of Q is the sine of the angle B. So the cos B here represents the X, and sine B here represents the Y. Reference to our video on unit circle, I explained that very good. Now, so you can see that Q has the point cos B, sine B. In the same way, S has coordinate cos A, sine A, and R has coordinate cos A minus B and sine A minus B. Very good. So we can say that the angle SOQ, the angle SOQ, that is this angle. The angle SOQ also equal to A minus B. It's also equal to A minus B. So since the central angle SOQ and POR, the angle SOQ and angle POR, note that they are the central angle, and these angles are equal, and these angles are equal. Very good. That is the angle SOQ and angle POR. They are all equal. Let's also look at the chord of PR, or the length of PR and SQ. Alright. By distance formula, note that this one, we can locate D1 here and locate D2 here. So by distance formula, we can say that PR is equal to SQ. By distance formula, we can say that PR is equal to SQ. Alright, and that is representing D1, and D2 here. Alright. So we know that which one is the D1? PR. Okay. We know that the formula for distance formula, in case we have 2 points, is giving us that is the change. That is going to be the change in S plus the change in Y. So the change in S squared plus the change in Y squared. So the distance from the B squared is equal to the change in S squared plus the change in Y squared. Alright. So since we have PR, the distance of PR being equal to SQ, here it's going to be square root. Here is going to be a square root. Very good. So let's first work on the PR. Then we later go and work on the QR. We can also combine all and work together. It will help in that way. Alright, so let me clean the board for us to go for that. Alright, so bear in mind that here we have the length, this representing the length of PR, and we are using the point of P, which is 1, 0, and the point of R, which is that. Very good. So the change in S, that is the change in S plus the change in Y. So the S1 is 1, and the S2 here is cos A minus B. So S2 minus S1, that is the formula for the distance. So this is S2, and that's what we have here, minus S1, which is 1, all squared. So that is the change in S squared. Plus the change in Y squared. Then we go for that. This is the Y. This is the Y1. That is P. Sorry, I'm referencing the S1. So that's P now. So this is the Y. This is the Y2 and this is the Y1. So Y1 and Y2. That is why we have sine A minus B, which is y2 minus y1, which is 0. Alright, and that is change in y squared. Very good. So this is f1 y1, and this is f2 y2. Very good. And from unit circle idea, you can represent that by that. Very good. In the same way, the length of QR is also the same thing. Where is the point of Q? This is the point of Q. And that is, I said QR. Oh. Q. It's rather SQ rather. SQ. Sorry for that. SQ rather. Very good. So the SQ, that is D2. Alright. So that one too, the same way. Change in S square plus change in Y square. So we have cos A minus, we have cos A minus cos B. Supposed to be cos A minus cos B. Yes, it's supposed to be cos A minus cos B. Because that is the change in X. The change in X. So cos A minus the cos B. So this one is S1, Y1. This one is S2, Y2. So cos A minus cos B all squared plus Y2 minus Y1. And that is sine A minus sine B. Sorry, this one will be S1, Y1, and this one will be S2, Y2. Very good. So that is sine A minus sine B. And that is what we have for the length of SQ. So now, for us to remove the square root, don't forget this is equating to this. So for us to remove the square root, we have to square both sides. So by squaring both sides, when we square both sides, and we need space, I cannot do this. All right. So when you square both sides, the root will go. The root will go. So we are going to get something like cos square A minus B. When you do that, that's what you're going to get. So make sure you do that. Cos A minus B plus 1 plus sine square A minus B to be equal to, but we need more space. So I would like to clean this part. Okay, to be equal to, that is for the right hand side, that one will be equal to cos square A minus 2 cos A cos B plus cos square A plus sine square A minus 2. Okay. Minus 2 sine A, 2 sine A, sine B. Make sure you continue with it. Alright, sine B plus. You can also choose to do the right hand side, then after that, come and do the left hand side. You can do the right hand side, then come and do the left hand side. Alright, plus sine square A, sine square B rather. They are all just algebra. Very good. And now, looking at what we have here, we can see that, you know that cos square A plus. So now what we have, we are going to simplify it. So this gives 1 from Pythagorean identity. That is going to give us 1. Alright. So we are going to get instead of writing this, you are going to replace it by 1 for any value of x. Alright. So we can now write to get 2 minus 2 cos A minus B to be equal to 2 minus 2 cos A cos B minus 2 sine A sine B. Very good, very good. So this gives 1, and not only that, why is it that this is giving 1? Because the arguments are the same. You see that the arguments are the same. So in the same way, the argument here is A minus B, the argument here is A minus B. Here is cos square, here is sine square. So bear in mind here also that this and this two will combine to give you 1. Alright. So you know this and this gives 1. So we are going to get 1 plus this one, that is 2. And this minus is what we have here. So the whole of the left hand side is simplifying to give you this. I hope it's clear. Very good. It's just algebra. That's why I'm just writing it down for you. Because this cos square A minus B plus sine square A minus B is 1. And cos square A plus sine square A is also 1. Alright, that is why this side. This side, since here is 1. Since here is 1. And also we know that this, where is this? Cos A, cos square A, and where is it? Yeah, we have enough things to be able to know HA. It's not easy. Don't forget that this one we have is a continuation of here. Alright. So when this and this combine to give 1, this and this will also combine to give you. So this is the expression that we were looking for cos A minus cos B. Alright, don't forget that now this one is cos A minus B. What if we have A plus B? To find that one is going to be similar to what we have done. Alright, but you can manipulate what we have to get that by By rewriting, I'm coming, you can manipulate that to get cos A plus B. Alright. So for you to get cos A plus B, you have to rewrite this in the form. Know that this one that we have here is the same as A plus. We can write A plus B. Yeah, we can write A plus B as A minus B. Knowing that again. So this will be the same as cos A minus. Alright. B. So here, you can do that substitution here. Where you see A, put A there. Where you see B, put negative B there. Because this is the same as this. So we are writing it this way so that we can do the substitution here. So when you replace A by A here, no problem. A by B by negative B here. Here is going to be negative. So we are going to get this. Cos A cos negative B, right? We are going to replace that. Then plus 2 sine A sine negative B, right? So let's see what we're going to get. So we get cos A cos negative B, negative angle, don't affect cos. So that is the same thing. But here, the negative, this is sine, which is an odd function. So it will affect it. So we get minus. Where from these two? Oh, these two will clear off. Right? Because we divide 3 by 2, so that will clear off. So here, we get sine A sine B. And that is going for cos A minus cos A plus B. So this formula is true for that, or this expression is true for that, and this is true for that. Very good. So that is how we verify it. That is how we verify the cosine of a sine, the cosine of sum or difference, So that is that, and that is that. Make sure you take note of this. We are going to use it to solve more questions. All right. So these identities are important in calculus. These identities are important in calculus and useful in certain applications. Although a calculator can be used to find an approximation for cos 15 degrees. For example, the method shown below can be applied to get an exact value as well as the practice using the sum and difference identity. So we are, for you, even though you are saying that even though cos something like 15 degrees, you can use a calculator to do, but you will not get the exact value. But with this idea or with this expression, it can help you to get the exact value. And we'll be looking at some of the examples right now. All right, let's look at our first example. And we are to, don't forget, we are going to use these two formulas. We have to find the exact value of each expression. And the first one is cos 15 degrees, cos 15 pi over 12, and that. Alright. So looking at the first one, cos 15 degrees, you can use your calculator to get alright. But to get its exact value, the calculator can help you to get the exact value. So we need to go by using the expressions that we have just derived. Alright. So A, the solution for A. To find cos 15 degrees, we need to write cos 15 degrees as the sum or difference. It's not always the sum, but the sum or difference of two angles with known function values. With known function values. That is, it should be a reference angle. Alright? A known function value like 15 degrees is a known function value. 30 degrees, 45 degrees, 60 degrees. These are known function values. And also, alright, let me give you up to here. And that's what I mean. Alright, so that is that. That is the known function values. Since we know the exact trigonometric function value of 45 degrees, 15 degrees, 30 degrees, and 60 degrees, using it to find the exact value of any trigonometric argument is going to be function argument is going to be easy for you. Alright, very good. Even if you don't have your calculator with you, you can still do it. So let's go for cos 15 degrees. We are going to write 15 degrees in such a way that we are going to use two angles. By this angle, when you subtract or you add, it should give you 15 degrees. And it's not any two angles that you can pick like that, but it should have a reference number like what we have here. Very good. So looking at this, you can see that 45 degrees minus 30 degrees is going to give you 15 degrees. So using this to work will be much helpful. Also, you can use, we have so many alternatives. You can use it so far as you are using this. You can use it. You can use 60 degrees minus 45 degrees, and that one also will give you 15 degrees. Alright. So to write cos 15 degrees is the same as writing cos 60 degrees minus 45 degrees, or it's the same as writing cos 45 degrees minus 30 degrees. I hope you can see that. Alright. And let's use cos 45 let's use cos 45 degrees minus 30 degrees minus 30 degrees. Alright. So here, this represents our A and this represents our B. So we link up to this. Note that here, A minus B. You don't go for A plus B because the sign here is minus. So you go for this. So we are going to do substitution. In this, wherever you see A, put 45 there. Wherever you see B, put 30 there. Alright. And don't forget that B is less than A. Always B is less than A. So don't write it minus B 30 minus 45. Don't write it like that. Because 30 minus 45 will be giving you negative 50, which is wrong. The argument is always positive. Alright. So by substitution, do that. Cos 45, cos 30, being the degrees, plus Now you have to know these two formulas of it also. Sine 45 degrees, sine 30 degrees. Very good. And cos 45 will be giving you square root of 2 over 2 times cos 30 degrees will be giving you square root of 3 over 2 plus this will be giving you square root of 2 over 2 times sine 30 will be giving you half. Okay. And square root of 2 times square root of 3 will be giving you square root of 6. Square root of 2 times 1 will give you 2. 2 to 4. 2 to 4. Alright, so that means that we are going to get the same denominator. I would like to read this part. That means that cos 15 degrees will be equal to square root of 6 plus square root of 2, all these over 4. So you see, this is the exact value that we are looking for. But your calculator cannot give you this. But with the help of this expression, you can get that. Very good. Let's go for the second question. Five pi over 12. Now, with this, you see, most of the times we don't like working in radian. But this is given to us in radian, so we have to work in radian. But you can convert it to degrees so that finding the two angles to subtract will be easy for you. So 5 pi over 12 is the same as 75 degrees, and you know how to do that. That is by multiplying it by pi over 180, and you get 75 degrees. Alright. Now, after getting the 75 degrees, which two numbers that you are going to subtract, and it's going to give you the same as 75. And you can see the two values or the two angles should be coming from these 4. 1, 2, 3. So let's look at the one that is going to get us. So let's see. What if we pick 30 plus 45? 30 plus 45 will be the same as 75. You can have another alternative way that when you do, you get 75. But for me, I'm going to use 30 and 45. Or 45 plus 30. The same thing. So this is going to give me 45. Alright. As I said, the two values or the two angles you take should be coming from this. If it's not, you are wrong. Now, the question is not in degree, but rather in radian. So you now count back. 30 degrees is the same as pi over 6. And 45 is pi over 4. So this gives 5 pi over 12. Then you can review that. Alright? Thank you for your understanding. So this is the same as cos. So this will be A, this will be B. But we are not going for this minus, but we are going for this. So we are get cos pi over 6 times cos pi over 4 minus sine pi over 6 times sine 5/4. Alright. And this gives square root of 3/2 times square root of 2/2 minus this gives half times square root of 2/2. And the final answer is going to be square root of 6 minus square root of 2. All these one. And that's going to give that, and that's going to be the exact value for that. Let's try on the C. Oh, that's the easiest one. Now C. Okay, so look at this. Cos 87 degrees, cos 93 degrees, minus sine 87 degrees, sine 93 degrees. So you just need to go for the argument, okay? This expression is linking up to this right answer. So you just go for A and B. A will be 87, B will be 93. Since this is similar to this, then we go for cos A plus B, which is the same as cos 87 plus 93. And you go your way. When you add 87 to 93, you're going to get 180. So this is the same as cos 180. And that is going to give you -1. Very good. Just watch your calculator, you're going to get -1. Alright. So that is that. In our next video, you'll be looking at, please watch before I close. You see, it's not only cos A plus or minus B that we have. We also have sine A plus or minus B. But that one, whatever we have done in this video is similar for the one for sine. Alright? So we just need to go for the formula for sine, and that is all. You just need to go for the formula for sine, and that is all. The examples and everything, they are all the same. Alright, so let me give you the formula for that. How we write the examples and everything is the same. So sine A plus B will be equal to sine A cos A, sine A cos B plus, the difference is that here the sign change, but here the sign don't change. Here cos, sin, but here is cos, sin, cos, then cos, sin. That's how it is. So here cos pick B, here cos will pick A, then sin B. Alright. The next one, sin A minus B will be equal to sin A cos B. Here is plus. Sorry, here is minus. So here will be minus. Then we get cos A sin B. So that is the formula for that. And how we work the examples is the same thing. So for your assignment, changing this to sine. This to sine. But the results may not be the same. Sine Alright, so go and work on this. See you in the next video. In the next video, we are going to look at co-function identities. Co-function identities. And trust me, you are going to learn. Thank you. See you in that video. Don't forget to subscribe.